Fellow Colonet Africa online students, welcome to our third lesson on this topic of salts. In this lesson, we shall continue our discussion on solubility of bases in water that we introduced in our last lesson, that was lesson 2, and also we shall look at the crystallization. Let's look at the discussion on the solubility of oxides. The oxide of potassium and sodium are soluble in water to form alkaline solution. Potassium hydroxide and sodium hydroxide are normally used to absorb carbon dioxide gas to form their respective carbonates. If you remember, when you're looking at in form 1, in fractional distillation of air, we used potassium hydroxide and sodium hydroxide to remove carbon dioxide from air. This is the equation for the reaction between sodium oxide and potassium oxide and sodium oxide with water to form potassium hydroxide and sodium hydroxide solution respectively. The oxide of calcium and magnesium are slightly soluble in water, and their solution is also alkaline, and it turns lead litmus paper to blue. And this is the formula, or this is the equation, and the other equation. These oxides dissolve in water to form their respective hydroxide, the calcium hydroxide and magnesium hydroxide. The calcium hydroxide is normally used for a test of carbon dioxide, since it gives a white precipitate when carbon dioxide is bubbled in it, and this is because of the formation of calcium carbonate, which is insoluble salt. Magnesium oxide is normally used to neutralize the acid in our stomach, hence it is used to treat the heartburns. Remember, traditionally people used to use a solution of ash in order to treat the heartburns, and that ash, the concentration of magnesium hydroxide is so high, that means when you dissolve ash in water, you get a solution of magnesium hydroxide. And this magnesium hydroxide, which is normally referred to as milk of magnesia, is the one that is normally used to neutralize the hydrochloric acid in our stomach, which is responsible for the heartburns. Oxides of zinc, aluminium, lead, copper are insoluble in water. Ammonium oxide do not exist. Potassium and sodium hydroxide are soluble in water. The hydroxide of calcium and magnesium are slightly soluble. The resulting solutions are alkaline, and hence they turn lead litmus paper or lead litmus solution to blue. This is the equation showing the dissolving of the hydroxide of potassium and the hydroxide of sodium to give their respective solutions. Then we have calcium hydroxide dissolves in water to form calcium hydroxide solution. So you can see the only change is in the state from solid to aqueous. That means this is not actually a chemical reaction, it's just a physical reaction. Then magnesium with the same, it's slightly soluble. Ammonium solution, also known as ammonia, water, ammonium hydroxide, aquammonia, aqueous ammonia, or ammonium. Ammonia is a solution of ammonia in water, and it normally exists in form of equilibrium between ammonia, water, and ammonium hydroxide. So this is the equilibrium equation. We have ammonium in liquid form, water in liquid form to form ammonium hydroxide. And ammonium hydroxide is used as a cleaning agent and sanitizer in many households and industrial cleaners. Ammonium hydroxide is also used in the manufacture of products such as fertilizer, plastic, rayon, and rubber. Aqueous ammonia is corrosive to aluminium alloys, copper alloys, and galvanized surfaces. Let's look now at crystallization. Normally, crystallization is a process that is used to obtain crystals of salts from their respective solution. Let's look at how you can obtain copper 2 sulfate from a copper 2 sulfate solution. This is a procedure. Measure about 20 centimeter cubed of water in a beaker. Add a spatula full of copper 2 sulfate crystal in the beaker and stir. Continue adding until it doesn't dissolve anymore. Decant a portion of the solution into an evaporating dish. Place the evaporating dish on a water bath and heat. Evaporate the solution until it is about to form crystals. Dip a crane rod in the solution and hold it up in the air to cool in order to find out if this point has been reached. Examine the rod to find out whether the crystals have formed on it. Continue heating until crystals are seen on the grass rod whenever the rod is dipped in the solution. Allow the solution to cool slowly to form crystals. Observe the crystals with a hard rinse. To obtain large crystals, cover the evaporating dish with a perforated paper. Leave the setup undisturbed and observe after 12 hours. Filter off the crystals and dry them between filter papers. When a spatula full of copper 2 sulfate is added into water, it is dissolved to form a blue solution. Remember, anhydrous copper 2 sulfate is normally used as a test for water. In other words, it turns blue when water is added. As more and more of salt is added into the solution, a point is reached, and this point is where we have no more solid or crystals can dissolve, and therefore you're going to find that some crystals remain at the bottom of the beaker because they cannot be able to dissolve anymore, and this point is referred to as saturation point. The resulting solution is said to be saturated, and a saturated solution is one that cannot dissolve any more solid at a given temperature. We are talking about at a given temperature because you find that as you increase the temperature, you increase the solubility. Heating increases the solubility of the salts in water. As the hot saturated solution cools, it forms solid particles with a regular shape. These solid particles formed are called crystals, and the process is referred to as crystallization. Evaporation is not done to dryness so that larger crystals may form. Slow cooling allows salt to form larger crystals. So if you cool very fast, you're going to find that you don't get crystals, rather you get powder. Otherwise, the crystals formed would be small. Crystals of some salts contain some water in a fixed proportions, and that water is normally referred to as water of crystallization. The salts are said to be hydrated, and that fixed amount of water is referred to as water of crystallization, and it's the one that gives us the shape of those crystals. This water of crystallization is important in the formation of crystals for hydrated salts. Crystals of copper 2 sulfate are not dried by heating, since heating would drive out water of crystallization, leaving behind a powder, which is anhydrous copper 2 sulfate. Powders and white crystals have irregular shape. In other words, they don't have regular shape. Examples of hydrated salts include sodium carbonate, decahydrate. Deca means 10, and that's why you see 10 molecules of water coordinated or incorporated in the structure of the sodium carbonate. Let's look at this table. I'm going to look at particularly this column of the name of hydrated salt, chemical formula of hydrated salt, and the common name of hydrated salt. Copper sulfate pentahydrate. Penta means 5. So the anhydrous, or the chemical formula for the anhydrous salt, is copper sulfate. Is that this formula? And you can see between this formula and this formula, this has 5 molecules of water coordinated to the structure. We use a dot to show that this water molecule is coordinated to the structure of the copper sulfate salt. Then we have cobalt chloride hexahydrate. Hexa means 6, so we have 6 water molecules. Before I come to this one, this is called blue vitriol. Blue comes from the color of copper. Copper sulfate solution is blue, and that's why I call it blue vitriol. That's the common name. Then calcium sulfate dihydrate is called gypsum. That's the common name. It has 2 water molecules coordinated to the structure of calcium sulfate. Iron 2 sulfate heptahydrate, it's a green vitriol. The green comes from the solution. The iron 2 solution, or the iron 2 sulfate solution, is normally green in color, and it has 7 water molecules coordinated to the structure. Sodium carbonate decahydrate, it's called washing soda. It has 10 water molecules coordinated to the structure of sodium carbonate. Sodium sulfate decahydrate is Grauber's salt, 10 molecules of water coordinated to the structure. Epsom salt, this is magnesium sulfate with 7H2O. It's called magnesium sulfate heptahydrate. It's normally used. Then that brings us to the last it brings us to the last bit of that lesson, lesson 3. So you have 10 questions to look into. Make sure that you answer all the questions. The answers are provided in the Word document accompanying this video. All the best, and let's meet in this further lesson of this topic next time. Bye. Have a good one.